Hey everyone, my name is Andrew. Thank you, Todd, for the kind introduction, and I'm excited to be here to talk about web components this week. Before I get started, I just wanted to share this URL. This is the URL for the live presentation slides. So if you open this URL on an internet-connected machine, you should be able to follow along with the slides. As they progress up here, they should progress on your computer as well, and hopefully this way you can follow along if you're not able to see or whatnot. You can also move throughout them if you want to look at a slide you missed or something later on. So these will all be online after. I'll leave this up for just a minute.
I'll also post that on my web notes page.
All right, awesome. And I plan on still using the Slack that's been used throughout the training, throughout the bootcamp. So if people want to post links or post questions there, I'll try to get to those. And we can use that to share examples throughout the week if we want to share code. All right, my name is Andrew Rhoda. I'm a JavaScript engineer at Wayfair.com. If you're not familiar with Wayfair.com, we're an e-commerce site. We sell furniture and home goods. We're based in Boston. I'm on the JavaScript team there. And so I'll be talking about web components, which involves a lot of JavaScript, but I'm also happy to answer any questions about JavaScript in general, about building web applications, etc. I'm from Boston, flew in last night. I'm also a contributor to Tungsten.js, which is a library that we wrote at Wayfair. I'm happy to chat more about that, but it's a virtual DOM library that we wrote to integrate virtual DOM into our web application stack. We'll talk a little bit about that. Most of the day, my view looks like this, just looking at code. I actually prefer my view to look like this. I'm a sea kayaker, so I prefer to be out on the water. But unfortunately, I'm from Boston, so this winter my view looked like this. We had record snowfalls, which was a little bit unfortunate. Actually flew out to San Francisco this winter just before the first huge blizzard hit, so just made it out. I do a lot of JavaScript. That's my kind of day-to-day work, and it's what I've been doing for quite some time. I use Backbone.js primarily. How many are familiar with this library? Yes. All right, cool. We got some fans.
Dude, I told you that guy right there is going to be happy to see you.
Awesome. Yeah, we should talk. We can definitely talk about that. Yeah, so I've been using Backbone for a long time, actually, before my current position as well. I've done a little bit of React as well, and then I mentioned this library called Tungsten that I work on day to day, which actually uses Backbone under the hood. And I think web components are pretty cool. I've had the opportunity to give a few talks on this, and we'll talk about why web components are pretty neat and why they have a lot of promise in terms of the future of the web. One of the things you'll notice about a couple of these presentations that I've given was one was on React, one was on Backbone. A lot about web components is how you fit into other paradigms, how you fit into other libraries and frameworks and whatnot. And we're not going to really go into learning all these new frameworks and libraries. This week we're going to focus on web components themselves. But I want to point this out. This isn't like some new technology that has to be used in a silo that's independent from everything else in the ecosystem. This is really about fitting into everything else that's out there, being interoperable, being portable, etc. So yeah, we're here to talk about web components. Web components is a topic. We're going to be here for a week, so we're going to get to dive in pretty deep on them. But at the end of the day, it means we're talking about HTML. It means we're talking about JavaScript. It means we're talking about CSS. It really means we're talking about new ways to use all these existing technologies. This isn't a new language. It isn't a new framework even. I like to think of it as a new way of thinking about how we build applications. And there are certainly new technical details as a part of that, new technologies, new APIs. But it's about leveraging what we know, what we've done before, take it to new levels. How many here have used all of these technologies before? All right, so that's awesome. I know there's been some really solid bootcamp training so far for HTML, CSS, and JavaScript. I'm going to be building on that, but if you're new to anything, or if I say something that you haven't done before, please ask a question. I'm happy to go into deeper detail on something, or it's very likely that something comes up in any of these technologies that you haven't seen before. And if you haven't seen it, someone else probably hasn't either. So definitely ask the question. we're here to talk about technologies, but we're also here to talk about patterns. Here to talk about how we build applications, how we structure them, and how we structure our modules within our applications. And so while these technologies are really important, I think these kind of more fuzzy topics are almost more important. Right? Sometimes we can get lost in the nitty-gritty details and forget about the broader patterns that are more important. How many come from a different CS background or a different sort of engineering background? Economics, awesome. I was actually a philosophy major in college, so I come from a little bit of different background myself. Yeah, I mean, these apply across disciplines in a lot of ways. One of the things that I think is really interesting about front-end engineering in particular is that there's such a wide range of backgrounds in the community, and that diversity is really beneficial. We get a lot of different perspectives. We get to see a lot of different ways of doing things. And at the end of the day, if we're saying that engineering isn't about the code that we're writing every day, it's not just about the APIs, it's about the patterns, it's about the broader structure of things. I think Web Components has a really important role there. I think Web Components allows us to think both in terms of the low-level stuff, but also not miss the forest for the trees, to be able to see how things are changing, how things fit together. And that brings me to componentization, which is really why Web Components is here. This idea of composing large systems out of smaller components. This is a quote from Dijkstra from 1970. So one of the pioneers of computer science. And he says that large systems should be constructed out of small components, and each component should be defined by its interface and not by its implementation. And there's a lot in this quote, as short of it is. Start with large systems and small components. This is the idea of componentization, that we take something that's big and we cut it down into things that are smaller. But we don't just arbitrarily, yeah.
I really like that one line, that second line there, where it's each component should be defined by its interface and not its implementation. Like ultimately,
Yeah.
it's how does the user interact with it, and
Yeah.
who cares, on the back end, right?
Yeah, exactly. And that's, yeah, it's important. That line is important on so many levels. So interface and implementation has a very technical meaning in terms of, it should have a defined interface that we can swap out and not worry about what's under the hood. It also has sort of a mid-level meaning in terms of, developers are working with these components, and you don't need to know what's kind of within the black box. You understand components only in terms of, what their output is and what their inputs are, as opposed to how they're implemented. And then certainly in terms of a user level, we want to build these parts of our system so that, our end users don't have to worry about how they're built. Yeah, there's a lot of levels to this. It's, and that it was sort of, I think it's cool that I like looking at all these old quotes from early engineers, early computer scientists, and seeing, these aren't new problems that we're solving. These are problems that have been around, that have been solved in different ways for different technologies. This is from 1970, so we're looking, almost 50 years ago now. And so it's this idea of componentization. That's what this week is all about. I mean, we'll go into the details. We'll go into the details of these APIs. This is really about componentization. Fowler and Lewis, so Martin Fowler's kind of one of the predominant computer architect names out there right now, and he does some really brilliant work. And in an article they co-wrote, they note that a unit is independently replaceable and upgradable if it's a component. And that means that we can take that piece of our application, that piece that we've split into a smaller piece, a component, and swap out that component. We can replace it. We can upgrade it. We can change it. And we don't have to worry about the implications there. One of the biggest challenges in building web applications is sort of that integration point, that point between components, whether they're at a large scale or a small scale. And a component well written should be replaceable and upgradable. And that's a really important piece. So if componentization is taking these, this large system, this large something, and dividing it into smaller interchangeable pieces, that's not just applicable to software. I want to think about, in your day-to-day lives, what are the things that you see that are componentized? Maybe it's at a company where they divide the company into certain divisions. Or if you're an educator, when you're building out your course for the year, you divide it into individual pieces. Maybe you have an assembly line at a company and you're dividing your process into pieces. Or even in government, we divide government into these smaller composable pieces. And they're done to different degrees. Some of them are componentized better. Some of them are componentized poorly. I think you judge that by whether they're replaceable, upgradable, small, or interchangeable. So I want to keep thinking about that throughout the week. Software components is really what we're talking about, though. We have different ways of doing componentization in software. One of them is between libraries. So if you're working in any language, any technology, you're frequently going to be able to work with different libraries. If you're in JavaScript, you might use something like Backbone or something like underscore or jQuery. If you're using Java, you'll have your own set or whatever technology you're in. When we divide libraries in software, these are components. They're individual libraries. And then our interfaces, we talked about defining components by their interfaces. They're the function calls between them. So if you think about a library that you might use with JavaScript, the way we define the boundaries of that library are by the functions that they expose to the other applications, the other parts of your application. That's the interface piece. So we have our components and our interfaces. That's an important division.
So the interfaces for me is like one of those words that, it's a big word and it's an important word in programming because, from object-oriented you've got interfaces,
Mm-hmm.
which is, has to implement certain methods. And then here, are you using that the same way or slightly different? But the interface is like, so the library is kind of component, here's this pre-written code. And then we have ways in which we just interface with that pre-written code. Is that the way you're kind of referring to interface?
Yeah, it's at a very general level. So it's that idea of how we interface with that, how we interact with that component. And the object-oriented interfaces, it's not just they share the same word. It's because it's implementing this idea in an object-oriented paradigm. So in Java, for example, you might implement an interface. And that guarantees that your object that you're writing, your class that you're writing, implements certain methods that you're expecting to be there. But if you think about it, that's all about what componentization is, that I can swap out library B for library X, as long as library X also implements these two interfaces.
Those two functions or methods.
Exactly.
Yeah, because that's the methods or functions are kind of how it connects with the code.
Exactly. It's all about how it connects with everything else. In the real world, we have interfaces. I think like an electrical outlet is a great example of this.
Awesome.
We have electrical outlets right in the wall around our homes and offices. And we always know that if we plug something into that electrical outlet, it's going to work. It's always going to get the same amount of volts and have the same specifications. In fact, we're very specific about what those specifications are, so much so that if you go to different countries, you have different specifications for those interfaces. And to take the analogy even further, we even have adapters between outlets in different countries, right? In the same way, in software, we write adapters on top of our interfaces to adapt one library to another that might not be compatible out of the box. It's really the same concept. And we don't just have libraries in software, we also have web services. So how many have used something like REST or JSON API or Firebase maybe, so these are all different ways we use HTTP APIs that are essentially web services. They're ways we communicate over the web. The important thing that's kind of different from libraries to services, when we talk about web services at least, is that you don't just have function calls. Now, because your transport mechanism is specific, it's kind of a little different than if you were all working in the same local environment. Now you have to do things like post calls or get calls between services. Or you have to do remote procedure calls. RPCs are a little more old school, but they exist, and there are different ways that we can make requests over the wire when you have a limited information mechanism for communicating between services. But these are still interfaces. They may not be the function calls that we're used to, but they're still interfaces. In fact, when we talk about a RESTful API, we're talking about an interface. It's not an interface of function calls, but it's an interface to our information. It's an information interface to our data.
Can we pause on that
Yeah.
Let me just see a show of hands. When he says RESTful, how many people first of all know what the acronym REST stands for? Raise your hand. You could say REST stands for
Cool. Let's go into that a little bit.
representational state transfer. What's that mean?
Yeah. So REST is a mechanism for defining APIs on the web for dealing with state across different systems. In particular, dealing with content. So REST kind of focuses on everything being some type of document, and in a RESTful system, we get documents, we change documents, we modify documents. The web is, in a lot of ways, inherently RESTful. So when you go to a website, really what you're doing when you open your browser is you're making a GET request to an endpoint, making a GET request to another server somewhere, and you're getting back a whole bunch of information, structured information, that's going to tell you about itself. It's going to provide the information that you need, but it's also going to tell you about its relationships to all the other content it relates to. We call those links. We're really used to them because we click on them. It's just sort of a really natural thing that we do and don't think about that paradigm. But that's really an inherently RESTful way to access information. And in these cases, again, these are all interfaces. We access a website, and we have an interface to be able to communicate with that server in different ways. So we can submit a post request for a form if we're filling out a form and hitting the submit button. We can click another link and make another GET request to something else. We can make a call to a system if we're doing it over a command line, or if we're doing it through another piece of software we wrote, or maybe through a website through some sort of middleware system. We can make a request, for example, to do something. We can tell a computer to process my request, or process my insurance claim or something. And maybe that's going to go to a system that's going to take a long time and get back to me later. But these are all methods that we communicate with systems on the web. We also have UI components. And this is, I think, this is the core of what we're talking about with web components. Or this is where at least we're starting to get there. They're not really web components yet. One of the things that's sort of frustrating about web components, and we're not going to actually go into the actual web component APIs until the end of today. We're going to build the foundation up before then. Web components is like a super generic name. Whenever I reference web components and I kind of capitalize the W and capitalize the C, that means I'm talking about the actual web component spec that we'll be talking about later. But components is a general term. Unfortunately, web components makes it sound like it's general as well, but it's very specific. So forget about kind of web components specifically and just think about UI components right now. Think about kind of general components as we build them out. So UI components, user interface components. What are the pieces of our user interface and how do they communicate with each other? Now we have user interface components within software on all different types of platforms. So you might have them on an Android phone or on an iPhone or on a native desktop app. We're going to be talking about web, UI components on the web in particular. And that's important because that involves HTML. It involves the DOM. But just think about this from a high level. If you open up a web page, what is on the page? What are the user interface components that you see? You might have a nav bar, a menu. You might have a set of tabs. You might have a content pane within those tabs that something opens up. These all are components as well, and they all have interfaces. With a nav bar, you might be calling a function when you click on an item. Maybe it changes something on the page. With tabs, you might have events that tell the content pane to open up. The content pane might be listening to an event, for example. This is how these sort of UI elements communicate on the page. They're their interfaces. If you think of a really basic application, some sort of website. When I say, I'll use the term website and application sort of interchangeably. I think there's a growing, it used to be that we define them very differently. It's like a web application is a single page app that you open up and load a set of HTML and then communicate with JavaScript from there on out and nothing. That's a web application, right? And a website is you open up a page and you click a link and you go to another page. I think that line is blurring. I think in a lot of ways there are a lot of web applications / sites that are somewhere in the middle. A lot of websites start to transition towards being applications. A lot of applications now are trying to be sort of server-side rendered on first page load. And so there's kind of a gray area there. So I'll use the terms interchangeably. If you think about an application or site, right, we have a lot of components here. And you can sort of start to imagine them in your mind. Like think about, if you were to draw red lines on here, where would you draw the lines? This is part of componentization, is thinking where you would draw the lines, because we could just arbitrarily draw lines. If I wanted to split this up into pieces, I could split it up into a grid. But that's not really smart componentization. We talk about componentization, it's about finding for your particular use case, for what you need, what makes sense. What makes sense in terms of organization? What makes sense in terms of interfaces? Maybe there are pieces that are just kind of logically grouped together. Tabs, for example, and their panes are kind of grouped together. There might be pieces that really stand on their own, like this header. It doesn't do anything else. We also nest components. That's certainly part of this. So, in this case, we have a map and a callout. Those probably aren't going to be completely independent. They're going to rely on each other. That doesn't mean we just have to have one big component. It means that we think about how we want to compose these components. And so, I pulled out the Boston Globe, and yeah, I think it's interesting to think about where would I draw the lines here. Maybe they would, maybe my header here, I'd have a whole bunch of different components for, say, the weather here. That kind of makes sense, right? Like, I might have a weather component that I develop independently. And if we think about, we need it to be replaceable and interchangeable and upgradable, it's easy enough for me to replace this weather component with something else. Maybe the location changes. Maybe I want the weather to change depending on which suburb of the city I'm in. We have an ad here. That seems something that's replaceable all the time. In fact, even within the user browsing my site, that's likely going to change. The news articles are certainly going to change. They can change every day, probably throughout the day. And so you can start to think about how these fit together. And there's some things that won't change. There's some things that will stay the same. The header, the navigation. But I think it's important to start thinking about how we make these divisions. How would you divide an application or a website into components? All right, so once we've divided our site into components, we have to start thinking about what's in those individual components. On the web, there are three divisions that we traditionally make. The first is structure and markup. Second is the styling, how it looks. The third is the actual functionality, how we interact with it. These correspond with the three main technologies we use on the web. So we use HTML for our structure, we use CSS for our look and feel, and we use JavaScript for that interactive functionality. One of the great things about components now is, now that I've split this up, if I go back to my components, I only have to think about the HTML, CSS, and JavaScript for one of those components. I don't need to think about it for my entire application. I can divide this out and separate that work and think about these in more understandable chunks. I think components really should stand alone. We want to think about components as being able to live on their own, independent of the rest of the application. They may have these interfaces that we communicate with it to the application. But if they're replaceable, we should be able to just replace them into nothing, right? We should be able to just pull them out on their own and use them. In the same sense, they really should be independent of their context. Components become less useful when we put all these restrictions on them. If we say that a component can only be this wide, or a component can only exist within a pop-up box, or a component can only exist in a certain space, that becomes hard to build these replaceable and interchangeable components. Components should be upgradable. Mentioned that at a very high level. I think at a lower level, that means we should be able to version them. We should be able to create components that, we have version 1 and then we want to upgrade it to version 2. Maybe you can imagine a button where you have version 1 and then you work with your designers and go through a redesign and you want to implement version 2. Components are testable. This is particularly important. We won't go into the details on unit testing or functional tests or integration tests, But testing is an important part of our application, whether we have automated tests or whether we do it manually. I think whether we know it or not, we're all TDD developers in some sense. And I mean TDD. So TDD is this paradigm, test-driven development, that you write your test first and then work on your development later, and then you go back on that loop and revisit it and make your test pass and write code and write more tests and write code and write more tests. That's very difficult, I think, to think about with a very complex system. How do I build these tests to make sure this huge ecosystem is working? It's a little easier when we start thinking about it at a lower level. Take a component here. The weather. I can test to see that if I get data from a weather service, say, and the weather service tells me it's 66 degrees, I can now test my component to see if it indeed says 66 with this little degree symbol. And that's easy to think about at a very component level. And we're already testing. We're already building our components or building our application and reloading the page and seeing if it works. There's that constant cycle of writing code, reloading, writing code, reloading. And testability is really what that's about, is writing code and being able to test that, whether that's a manual way or whether that's in a more automated fashion. So I think this week, I want to ask you to think in components, kind of shift your thinking in terms of application development to think about how we build sites in terms of these little pieces. If you see something, if you go visit a website, think about how you would break it up into individual components. Think about how those components would fit together. We're going to be doing some exercises throughout the week, and the goal at the end of the week is to have a collection of UI components implementing web components APIs. We'll get into that later, but the APIs are important and they enable this componentized thinking, but it's about the patterns more than the individual technologies. All right, so that's the first section. I'm going to go through some administrative notes about exercises and where everything is.
You want to stop recording?
Yeah, we can stop.